Alright guys, today's essential question is how do we factor polynomials? We're going to be looking at three specific types of factoring techniques. One includes greatest common factor with prime factorization. The other one is difference of two squares, and the last one is factoring trinomials. Alright, let's start off by just talking about what a greatest common factor is, or a GCF. Like, say for example, I have x to the third and x to the fifth. What would be the greatest common factor that they have in common? Well, x to the third literally means x times x times x. X to the fifth literally means x times x times x times x times x. Well, what do they have in common? They have three x's in common. So the greatest common factor for this would be x to the third. A general rule of thumb is that whenever you're talking about variables, your greatest common factor is always the lowest of the two, or the lowest exponent. So for example, if I ask you what the GCF of t to the seventh and t to the fourth is, the GCF would simply be t to the fourth, because it's the lower of the exponents. Even if I give you three terms, a to the fourth, a to the sixth, a to the second, the GCF would simply be a to the second, because it's the lowest exponent, and that's the greatest common factor. Alright, now let's talk about actual terms. So let's say I wanted you to tell me what the GCF of 12x to the third and 16x to the fifth is. Well, 12 can be broken down into 4 times 3 and 4 into 2 times 2. So the prime factorization of 12 would be 2 times 2 times 3. X to the third would be x times x times x. 16 you can break down into 8 and 2, 8 into 4 and 2, and 4 into 2 and 2. So its prime factorization would be 2 times 2 times 2 times 2 times x times x times x times x times x. Well, what do they have in common? They have two 2's in common, and they have three x's in common. So the GCF would be 4x cubed. Just note that 4 goes into 12 and 4 goes into 16. Alright, let's take a look at the second one. What about 45a to the fifth and 50a to the seventh? You can break down 45 into 9 times 5 and 9 into 3 times 3. So its prime factorization would be 3 times 3 times 5 times a times a times a times a times a. 50 you can break down into 5 and 10 into 5 and 2. So its prime factorization would be 5 times 5 times 2 times a times a times a times a, 1, 2, 3, 4, 5, a times a. What do they have in common? Well, they have a 5 in common, and they have 5 a's in common, so its GCF would be 5a to the fifth. Notice that 5 goes into 45, and 5 goes into 50. Alright, well, let's take a look at two more. Take a look at this one up here, 22x squared and negative 11x. I could break down 22 into 2 times 11, so its prime factorization would be 2 times 11 times x times x. Negative 11 can't break down any further, so it's just 11 times x. What do they have in common? Well, they have an 11 and an x in common, so its GCF would be 11x. Alright, for this last one, let's say that you had this polynomial, negative 4x to the sixth minus x to the fourth minus 2x squared. What I want to see is if I can factor out a GCF. Well, right off the bat, I see that this is x to the sixth, x to the fourth, and x to the second, so I know that its greatest common factor variable-wise is x to the second, because it's the lowest exponent. I don't have a number that I can divide out of each one of those, but I do notice how they all have a negative in common. So its GCF would be negative x squared. So I'm going to factor negative x squared out. Or you can put it understood 1, so negative 1x squared. What I'm going to do now is I'm going to divide each one of these terms by negative 1x squared. Well, negative 4 divided by negative 1 would leave me positive 4. And x to the sixth divided by x to the second would be x to the fourth. Alright, negative, understood 1, negative 1 divided by negative 1 would be a positive 1. X to the fourth divided by x squared would be x squared. Negative 2 divided by negative 1 would be positive 1. And x squared divided by x squared leaves you a factor of 1. So then this would be my factored form. I could test to see if this is correct by distributing that negative 1x squared back, and I'd end up right back in the same spot. So that's how you factor a polynomial by a greatest common factor. Now, another thing you might see is what we call a difference of two squares. In order for it to be a difference of two squares, or dots, first of all, the operation has to be a subtraction. There has to be two of them, and they have to have square roots. So like for the first one, 9n squared minus 4. That is a difference of two squares. The square root of 9n squared would be 3n. The square root of 4 would be 2. Just remember, one's positive and one's negative. The next one is a difference of two squares. The square root of w squared is w. The square root of 49 is 7. Make sure one's positive and one negative. The next one is not a difference of two squares because there is no square root of 8, so I can't factor that one. The next one is the square root of 81 is 9k. The square root of 100 is 10. Make sure one positive, one negative. The next one is not a difference of two squares because it's got a plus sign between them. The next one is the square root of 16d squared is 4d. The square root of 225 is 15, so one positive, one negative. The next one is not a difference of two squares because there's three terms, not two. The last one is a difference of two squares. The square root of x squared is x. The square root of 9y squared is 3y. Just make sure that one's positive and one's negative. Difference of two squares is pretty easy to factor. All right, for the last group is if you have a trinomial or three-termed polynomial. X squared plus 9x plus 14. Notice there's no GCF, and it's not a difference of two squares. So how do I factor this? Well, what you do is multiply the first number, which is understood 1, times the last number, 14. So that gives me 14. List the factors of this number. So 1 and 14, 2 and 7. I want to pick two of these factors that will give me my middle number. Well, 7 plus 2 will give me 9. So that will give me 1x squared plus 7x plus 2x plus 14. And what happens is I have four terms. So I can group these into two sets. Look at my first set. What's my GCF from this first group? Well, they have an x in common. So I'm going to take out an x, and that will leave me x plus 7. In my second group, they have a 2 in common, a positive 2. So I'm going to factor out that 2, and that will leave me x plus 7. I'll know that I did the work correctly if these two things are the same. Now that these are the things that they have in common, the x plus 7, I know that's my GCF for that group. And then what's left over, the x plus 2, goes in the other binomial, and there's my factored form. Again, I could test to see if this is correct by foiling this back out, and I would end up right back where I started. All right, take a look at the next one. Understood 1 times negative 20, so I need factors of negative 20. Well, that could be 2 and negative 10. That could be negative 4 and 5. That could be 5 and negative 4. It could be 1 and negative 20. It could be negative 2 and 10. It could be negative 1 and 20. But remember, you're trying to get this middle term, which is understood positive 1. Well, what two factors will give me positive 1? I think negative 4 plus 5 would give me a positive 1. So I'm going to have 1x squared minus 4x plus 5 minus 20, 5x minus 20. I've got four terms, so I'm going to group them. I'm going to look for my GCF in the first group, which would be x, and that will leave me x minus 4. Look for my GCF in the second group, which will be positive 5, and that will leave me x minus 4. I know I did it right because these two match up, so I have x minus 4 is my GCF of that, and what's left over is x plus 5, and that will be my factored form for that. All right, continuing on. For this next one, understood 1. So 1 times negative 14 is negative 14. So list my factors of negative 14. I could use negative 2 and 7. I could use negative 7 and 2. I could use negative 14 and 1. I could use 14 and negative 1. But remember, I'm trying to get a positive 5. So what two numbers will give me positive 5? I think the negative 2 and the positive 7 will. So 1x squared minus 2x plus 7x minus 14. I've got four terms. Group them. My GCF in the first term will be x. That'll leave me x minus 2. My GCF in the second group will be positive 7. That'll leave me x minus 2. I know I did it right because x minus 2 is the same, so that's my GCF, and what's left over is x plus 7, and there's my factored form. Last one, number 2, number 9, so that'll be 18. Factors of 18 would be 9 and 2, 1 and 18, 6 and 3, but I'm trying to get 11, so 9 and 2 would work, so 2x squared plus 9x plus 2x plus 9. I've got four terms, so I can group them. My GCF in the first group would be x, and then that would leave me 2x plus 9. If you ever end up saying, well, there's no GCF between the two, well, if they don't have anything in common, they at least have 1. So I can take out a 1, and that'll still leave me 2x plus 9, which notice I end up with the same thing in parentheses. That means I did it right. My GCF is 2x plus 9. What's left over is x plus 1, and that's my final answer. That's it for today's lesson.